The first step when you're multiplying the rational expressions is you're going to factor everything completely. And so you're going to factor the numerator and denominator of every single fraction involved in the operation. So in this case, multiplication. So we have the difference of squares in the top, so we can factor that into the sum and difference of the terms being squared. So that's x plus 3, x minus 3. In the denominator, we only have two terms, so we look to remove any common factors that we can. We can remove an x, leaving an x minus 3. In the next fraction, we have a numerator with a monomial factor, so that's already a factor, just leave it. And then our denominator, when we look at this, we're looking for reverse foiling. For this, we know our first terms have to be x. We're looking for two factors of positive 18 whose sum is positive 9. And what are those factors? 6 and 3, so plus 6 and plus 3. So there's our first step. Okay, so we're just going to leave or factor everything completely in the entire, every fraction. Okay, now what we're going to do is we're going to treat this all as one single fraction. And we're going to cancel common factors. Okay, so even though these are two separate fractions, if we just think of it as one big fraction where each individual factor is just that, a factor of the numerator or denominator, what we can do is we can cancel any common factor. So we have, as we go through, an x plus 3 that cancels, an x minus 3 that cancels, and the factor x cancels. So we canceled all of those. You're then going to write your simplified fraction as your answer. Okay, so all we have left is a 1 in the numerator and an x plus 6 in the denominator. And among the writing simplified fractions is going to be to identify any domain restrictions as well. Remember, these are the ones that are not apparent in the simplified form. Okay, so when we look at this, we go back in and we find the different factors. Again, all we have to test are the factors that got canceled from the denominator. So when we write these, we see that x can't be 0, x can't be 3, x can't be negative 6, and x can't be negative 3. We don't even have to worry about the negative 6 because that one's apparent in the simplified form. All we have to do is test the remaining ones, okay? And none of those are apparent in the simplified form. So when we list multiple domain restrictions, just list them from left to right on a number line. So the least number first. So negative 3 comes before 0, which comes before 3. And so that would be your final answer, including the domain restrictions. Okay. All right, let me have you try one more. Right. So the steps on this. First, factor everything completely. So in the first fraction's numerator, we have the difference of cubes. The bases being cubed are x and negative 3. So when we factor that, we're going to have a binomial factor and a trinomial factor. The binomial is just going to be the sum of those two bases, x and minus 3. The trinomial, we're going to square the first base. The last term is the square of the second base, so negative 3 squared is plus 9. And the middle term is going to be the opposite of their products. So x times a negative 3 is negative 3x. Switch the sign. So there's our factors of our numerator. The 4x is a monomial factor, so we just leave it as it is. The binomial of the second fraction has a common factor of what? 2. When we remove that, we're left with x plus 2. And finally, we have a reverse FOIL a trinomial that we can factor. We look for the two factors of negative 6 whose sum is negative 1, negative 3 and positive 2. And so now our first step's complete. We factored everything completely. We now move to the stage where we remove any common factors. So the x minus 3's cancel. This trinomial has no common factors. The 2 cancels with the 4, leaving a 2. The x plus 2's cancel. And so we write the resulting expression. So x squared plus 3x plus 9. That's the only factor in the numerator. And then we have a 2x in the denominator. So the last thing that we want to do is identify any domain restrictions that are not apparent in the simplified form. So if we go in and look at the factors that got canceled from the denominator, again, we only need to consider factors that have variables in them. So here we know that x can't be a 3 and x can't be a negative 2. We see that x can't be 0. I mean, that is a domain restriction, but it's not an additional one. We see that is apparent. That's an apparent restriction in the simplified form. So all we need to do is include negative 2 and 3. Again, write them in order from smallest to largest, and that would be your final simplified form.